Welcome to this introduction to EnergyPlus, one of the most powerful and widely used tools for building energy simulation. EnergyPlus doesn't just calculate a building's energy use, it simulates how buildings respond to internal and external environmental factors such as weather, occupancy, and equipment loads. With the growing emphasis on sustainability and the need to meet energy regulations, learning how to use EnergyPlus can help you design more efficient, comfortable, and environmentally friendly buildings. In this video, we'll walk through the basic steps to get you started, so you can comfortably navigate the interface and understand the fundamentals. In the future videos, we will explore more advanced topics like HVAC systems, integrating lifecycle assessment tools, and even linking EnergyPlus with Python for automation. So stay tuned. Well, as you may already know, EnergyPlus is an open source program and you can download it pretty easy from the website energyplus.net. Just go and click on the download button. You will find all the versions that are available. It's pretty reasonable to download the latest version, which is currently the 24.1.0, and you have to pay great attention that if you use this version, which is the latest one, and construct a IDF file, you cannot use the older versions to operate it and change the features. So just keep that in mind. And you just go and click on, if you have Windows, you click on this button and it will be downloaded automatically. After you download and install the EnergyPlus program, you'll find in the install directory the folder documentation, and inside it is the input-output reference, which is a useful document for the program. It carefully explains how each class list and component works. However, we're going to go through some of the basic components that you will need for any building modeling and explain how they work. So moving on, I will tell you more about this part. Today we'll be using this simple model that was sketched in SketchUp and exported as an IDF file later by OpenStudio gadgets. And here we have only two thermal zones, and one is the main room, and we'll work on that and assign people and different components to it. The next step is to open the EnergyPlus EP Launch application. In the first window is what you see right here. You have to assign an input file, which should be in IDF format, and an EPW file, which is for the weather file. And here below we have the components that are useful for the results, and we'll dive into it later. So to start, we have to open the edit IDF editor file, and clicking on it, a window will pop up, and this is actually a model of our building and the components that it actually holds, the IDF file from before. So here, if you press Ctrl and L simultaneously, you'll get the components that we already have and not the ones that are missing. So here the version is 22.1, which was from before that I modeled the building, and it doesn't really matter because the latest versions don't differentiate a lot. Here in the simulation control, some things that are important are the sizing calculations, which is something that EnergyPlus does. It actually calculates the amount of load, flow rate, and power of the HVAC system. It is according to the set point temperature and other set points that you put for the zones that have this system. And it is better to put them on the yes option unless you want to control them manually yourself. Whether you want to try to put a specific HVAC system or want to just see how these parameters work in respect of each other. So this is something that you can go through it yourself and maybe read more about it in the input-output reference. Since we're not going to assign any plant sizing calculations, we will put this to no, and it is actually useless in this file. After that, running simulation for sizing periods is something that hasn't been assigned yet, and we'll later talk about it. And we just set this to no. What this does actually, if you assign sizing periods, which are extreme weathers that occur in the calendar year that you will assign in the run period, and what you will do is that you make sure that the simulation runs on these extreme weathers, such as the hottest and coldest days of the year that I explained, and it will make your simulation more efficient. And we'll temporarily put this to no. After that, we see the run simulation for weather file run periods, which is exactly what I told you about. So if we don't put this to yes, it won't use the calendar file that we assigned to it. So this will be the simulation control part, and we'll move on to the next parts. The building class list defines the overall characteristics of the building model in EnergyPlus, including the building's latitude, elevation, and terrain. It actually sets up the foundation for how external factors like weather will affect the building. And the tolerances are put here to, they're at their maximum level, and this is related to how warm-up days works. EnergyPlus runs some warm-up days to see if the simulation runs properly, and the different warm-up days should somehow converge. And this is the value that you put to make sure your runs are efficient enough and can be relied on. The zone air contaminant balance is a feature that allows EnergyPlus to simulate air quality as well as other things such as temperature and lighting. Well, if you put this carbon dioxide concentration to yes, CO2 tracking will be on for our simulation as well. Time steps is an option that determines how often EnergyPlus performs its calculations. A smaller time step, such as 6 per hour, which equals to 10-minute intervals, increases the resolution of the simulation. So if you put 4 per hour, it equals to 15-minute steps, and 1 per hour means an hourly step. So this is up to you to see how efficient you want your simulation to be. Now what we're going to do is download a extra weather file to put in the site location input, and you can go just again to the energyplus.net website and then go to weather. You have different continents to choose from, and let's go with North and Central America, and we're looking in USA and Arizona. So here are different locations, and we went with Phoenix before. So here we have different outputs, then we are going to download the DDY file. When you open the DDY file and press Ctrl and L together, you'll find that there are only two class lists here present, and you can copy both of these by selecting them and then clicking on copy. So just have to paste them on the file that you're working on. So here, let me just delete this one and select paste, and it will automatically paste it on the site location direction. And let's go and copy this one too. These are the sizing period design days, the extreme weather conditions that I explained earlier. So we'll just go on and copy these here, and if we select paste again, they will automatically be pasted. Okay, it seems that only one of them has been copied, so we select all of them. After that, we're just going to have to paste them here. Let me delete this previous one and paste. It takes a while, and we should have different design day sizing periods that we'll use maybe later in the simulation. Okay, run period actually defines the time frame of your simulation, such as whether it's running for a specific day, a month, or an entire year. It allows you to choose the start and end of the simulation based on the weather data you're using. It's best to not change anything in this area because it is basically from the EPW weather file that we assigned to it earlier. Moving on, there is a concept of schedules, which is something in EnergyPlus that allows you to assign different numbers to different systems. So in schedules, we determine the operation time of different building components like lighting, occupancy, and HVAC systems, and so on. They ensure that the system in the building only operates during relative hours, improving the accuracy of the simulation by actually mimicking real-life operation patterns. And for example, we can say it's like turning the lights off at night. So if we want to dive into it deeper, I feel that schedule type limits is the best place to start. This part actually defines the type of values and their limits that a schedule can have. For example, you can specify whether a schedule uses fractional values, for example 0 to 1 for occupancy, integer values, or other numeric ranges. It also sets units like whether the schedule is in hours, temperature, or a simple on and off state. So helping to standardize schedules across different components is basically what this component does. And schedule day intervals, schedule week daily, and the schedule year are actually predefined, and it's better not to change anything in them. We will be mostly using the schedule constant. And here, what this part does, it actually creates a constant schedule where the value remains the same throughout the entire simulation period. Here you can see for this activity level, which is maybe used somewhere in the file, these are actually predefined. We can see that it has a lower limit value, it can have an upper limit value, and a numeric type. For example, is it continuous, is it discrete? And further, we can see there's a unit type, and what we actually talked about. Is it dimensionless, is it a temperature, angle, and so on. So you can find actually anything that you're looking for here. So these are for temperature, for example, and this is for availability. You see here the lower bound is 0 and the upper bound is 1. So either this person or people are present or not. So you can play with it based on what your goal is actually. I went ahead and pasted some schedule compacts from my own file. Here we can see a different scheduling tool. What this does, it actually allows to define detailed time-varying schedules in a compact format. This is one of the most flexible and commonly used scheduling objects, as it lets you specify different values for different times of the day, days of the week, or even specific seasons. And I will give a breakdown for you. It actually has a time-based variation, and you can assign different values like occupancy, lighting, or HVAC operations based on specific hours of the day. For example, you can set higher occupancy values during work hours and lower it during the off hours. And there's also an ability to choose day types. For example, is it a holiday? Is it the weekends? Or are we're talking about the weekdays? So this pattern is controllable also. And there also are seasonal adjustments. So we can say for winter days, this will be the schedule. And for summer days, the second scheduling will be set. So we can see here, like, this is a pretty simple one, and it was for a fan schedule. The value is fractional, and the first we have to choose from the start. It says that from the start of the date that we put in throughout the entire year, because it's the last day of the year. And so this schedule is basically for the whole year, regardless of the season. But here we can see the day type. It is for weekdays. You have to just write it exactly like this, and it doesn't have, unfortunately, any predefined objectives to like choose from them. You have to write it down, and we say, okay, in the weekdays, from the start of the day, which is after, like, in the first minute of the morning until 7 o'clock, the value is 0, which if we put this for a fan schedule, it means that it is not working. And after that, we just go through the hours of the day. For example, we say until 12 o'clock, the value is 1. Then it changes constantly, and we reach the final hour of the day, and we say, okay, until the 12 o'clock, 12 p.m., this is the value, which is 0. And for this building, which was a office, I put all other days, which are the holidays and weekends. The value is 0 until the midnight. So this just means that they're turned off. The fan is not working throughout the weekends and holidays. If you want to learn more on how to specify these weekdays or weekends and other stuff, you can look into the input-output reference that I told you about and just search, for example, for weekdays. And you will get to a part here which actually explains it pretty well. And you can see we have weekdays, weekends, holidays, all days, and so on. So this is why I tell you input-output reference is really helpful to you. So where you have a question and cannot find it on the internet, you can just search it here and then maybe go to other sources, and typically you'll find the answer right here. I know it's a bit complicated. It is 2,800 pages, but you'll find your answer here, sure. Moving on, I will explain to you how EnergyPlus controls the material and construction of the building. And here we can see at first the materials. For example, we have concrete, an 8-inch concrete. It has a roughness value, and you can set the thickness, conductivity, density, specific heat, and other stuff. And this depends on the material you're using. So you define them here. And by the way, when you want to define something new, you just hit new object here. The fields that are in blue color are the ones that you should actually specify. And if you don't address them, you'll get an error while doing the simulation. So if we want to assign a new material, you should fill all these blue colored fields, and there you will have a new material. So I just go on and delete this so I won't face any errors during the simulation. And these are actually, I think, fine for your goal, because if you want to assign new ones, you just have to search about them and fill these also. The other thing that I wanted to talk to you about was construction. Here we assign those materials that we previously assigned to this constructions. For example, we can see here a metal roofing. First, this is the name of the construction. It's an external roof. So the outside layer, we say it's a metal roofing. These are all the materials that we saw from earlier. And this is the outside layer and other layers that follow. So we have an insulation layer between these metal layers actually, and the end is the metal decking. So you can just check them out and create the construction that you like to use for your specific need. After that, we can see there are building surface detail and fenestration surface detail. In the building surface detailed, we can see the different walls, roofs, and floors of our model. And here we assign the constructions from earlier. So we assign them to the roof. For example, this is the exterior roof that we talked about, and we assign it to this specific roof in our model, which is the surface number 11, and we should go and see what surface it is. And here we assign the type of the surface. Is it a roof, floor, wall, ceiling, etc.? And after that, we point out the construction that we want it to be from earlier, if you remember here. And then again, it's up to us to assign these or not, because we're only looking for the blue colors. And we specify that this surface is in the outside, on the inside, and other specifics that it could have. And there's also a sun exposure item. So that speaks for itself. Is it on the outside? Does the sun is it facing the sun? And also for wind, this is a pretty simple concept, and these are the coordinates that if you construct your model in SketchUp program, you won't need to fill this in, and they will be automatically written here. Here we can also see the fenestration surfaces, which are mainly composed of windows and doors. And we should name them whatever we see fit. And here we should choose a construction name for them. We should find the for this example, it's a window, so maybe we choose like the exterior window, climate zone 1. And for the next one, which is a door, we should find the material for the door. For example, here the exterior door. We should predefine these in the construction part, and the building surface name is the surface that they are placed on, which here we can see they are both placed on the same surface, which here we can see is the fourth surface. Other than that, these options are not really essential, and here we have the coordinates to these specific detailed fenestrations. Moving on, we can visit the zone class list. A zone represents a distinct space within a building that has uniform environmental conditions, such as temperature or humidity. It is a fundamental object in EnergyPlus that allows you to model the thermal behavior of different areas in a building. And as you can see here, each zone has its own object, which thermal zone 1 is the for here it's the main space, and thermal zone 2 is for the attic, which is a small part here. And we have also the zone lists, and a zone list is a way to group multiple zones together. For example, if you want to say you have 2 living rooms, you can add it to a group and create actually a new object and say, okay, living rooms, and add the 2 thermal zones, which are the living rooms basically of your building. So here we don't have that, but it's just an option for you to explore later. The people object is used to define the number of occupants within a zone. This object is crucial for calculating the internal heat gain from occupants. That is something that can affect the thermal loads and overall energy consumption of the building. So it is pretty important how you define it. It considers occupant schedules, which can be assigned from the schedule, constant, compact list, or others. And in addition to metabolic rates and activity levels to determine how much heat people generate in each zone. So all of these are available here, and you can see the fraction radians and other stuff that you can fill in later when you want to specify the occupants of these spaces. I actually went ahead and pasted an example from my own project. This is the name of the space that these people are defined in, and the zone that they belong to. For example, here we say thermal zone number 1. Well, the number of people in the schedule room is something that is from the set points that we had before, or are predefined actually. You can set a schedule for this place, and in the schedule compact part you can say that okay, these people are present from 11 to 12 and so on. So this shows another use of the schedule compact list. And moving on, we can define the people that are present in the area in different ways. We can specifically tell how many people there are, people per area, and an area per person. So this is actually up to you. You can change this number and completely let's just give the number of people. For example, for this instant, 11 people are present in the building. And this is enough for a normal use and for assigning people to a zone. However, if we want to get more into details, we can specify an activity level schedule, which can be defined in these schedules that we mentioned before. Also, the carbon dioxide generation rate can be put to the default number, and this is something that you should put in if you want to calculate the carbon dioxide concentration in these spaces. And other than that, working efficiency, air velocity, and closing insulation is required if you like to use the Fanger's PMV thermal comfort standards and get the outputs on what is the thermal comfort actually value of people in that zone throughout the simulation. The last class list that we're going to talk about today is the sizing parameters. The subject defines the sizing criteria for HVAC systems, like how much extra capacity should be included to account for uncertainties or safety margins. This is basically to ensure comfort under extreme conditions. It allows you to set safety factors for both heating and cooling loads, and it can adjust the design conditions for system sizing, ensuring the HVAC systems are adequately sized to handle peak loads. And that will be enough for the first video on the tutorial for EnergyPlus. And later on we'll talk about how to run simulations and assign HVAC systems to the building that we have already defined.